Okay. Just in few words, I'll talk about the clustering. Okay, so let us assume that first I want to generate a data set. For sure, for you, you have already a data set which you can use. I'm going to generate some data set here. Okay, and assume I have three classes. Okay, the number of attributes is 10, and the number of examples is 2000, or number of instances 2000. And this is my seed. Okay, and I have all the uh, the instances are of type numeric, so 10, because here the number of attributes 10, so all of them are numeric. And just say okay, and then I'm going to generate data set. So this is my data set now. Fine. So now I want to use this my data set for the clustering. So I go to clustering, for example. Let me just come here, and when I select the cluster, I go to k-means. Now this is my k-means. Okay, and I can just use the training set. You can just change the percentage of splitting as you wish. Okay, you can use 70 to 30, you can use 75, you can use something. Then use the training set. Okay, and for me, I'm going to first uh, to ignore the class. Okay, because here you see, let me just first, I'll show this first. In this one, this is the class. I have uh, three classes, as I told you, C0, C1, C2. Okay, and this is the distribution of the class. So I have 118 related to class C0. I have 991 related to C1, and I have 891 related to C2, and the total should be 2000. Okay, fine. So now let us go back here, and let me just ignore the class, because I should, once I'm doing the clustering, I should not do include the class. Here, let me just do the start, okay, using the training set. Okay, so now according to this, okay, I have to change here. This is not the correct run, because I have to specify it as three clusters. So here, which is the number of classes there, which I have. So here, three. Fine. And that's it. Okay. Okay, for sure you can change the seed. Instead of 10, you can make it, for example, 4. You can keep it 10 as you wish. Okay, and now let me just start. I have already ignored the class. So I have now three clusters. Okay, cluster number 0, cluster number 1, cluster number 2. And these are the number of instances distributed to clusters. So for the cluster number 0, I have 32%. For the cluster number 2, I have 38%. And for the class number 2, this is class number 1, cluster number 1, cluster number 2, I have 31%. Okay. And just because I want to see, like, if my clustering works well or not, I can just do this using the classes to cluster evaluation. Okay, so just this will help me to see whether the clustering is doing like the or distributing the instances as what we have in the classes or not. Okay, so here I can just start. It's already ignored. No need to do it again. Okay, so no need. And you can just say start. Let me just, before that, let me just give some explanation here. So, for every cluster, we have a center for the cluster. We have 8 continuous values, or 8 real values for A0, A1, A2, A3, A4, A5, A6, A7, A8, and A9. Okay, these are the values for the attributes which we have here. Okay, these are the values for the attribute which we have as the center. Okay, the center of cluster 0. The same thing. So these are the initial values from which the k-means started. Then after the doing the or processing the model, okay, it will just uh, have the values like for the A0, A1, A2 up to A9, okay, the clusters just will be here. These are the values for each one of these attributes. Okay. So now this will be the values for the last center for the class or the cluster. Sorry, I'm talking about this. Sorry. The cluster 0. Okay, this is for these are the values for the center A0, A1 for the center of the cluster 0 after modifying these values in the center 0. This one after modifying this. Okay, and so on, applying the k-means algorithm. Okay, anyway, and now this is what we get as I explained before. Now let us do this, which we want to see the classes to cluster evaluation. So I just make start, and you see here the percentage of incorrectly clustered instances is this much, which is 1,145 instances. They have been incorrectly clustered instances with a percentage of 57.25. For sure, you can change and try. Maybe you can make here, instead of having 500 iterations, you can make it, for example, 1,000. I don't know if this will change or not. You can also change the seed, for example. You can make it 6 more. For example, I'm saying just a minute. Okay, to see. So here, that's what we want to have, for example. And don't forget that the percentage of incorrectly classified instances or clustered instances is 57 point something. If I do another run with these new defined parameters, I'm not sure whether I'm going to get a better accuracy or worse. If I get lower than this value, it means it's better. Okay, for sure. But if it is more, it is worse. This is worse. This is worse for sure. Okay, let us try another one. Assume I have here again. Let me just start from another another seed maybe. Okay, so for example, I can make it 7. And let me just start again and see. Again, 61.4. We can change again. And let me just see again here. Let me just make this one 700. And here, let me just make this one 6, for example. Okay. And let us see. Again, very close to that. So anyway, maybe this depends on the actually the because the data is generated at random. And maybe if you try to on some real data, things might differ. But anyway, this is the way how you work. Okay, so now this is how we can do it. The other thing that I want to mention is that you can just try, for example, another classifier. Could be the hierarchical classifier or some other classifier. So if I use the hierarchical classifier, for example, for the same data set, okay, I can just do the same thing, okay, using the class 2 cluster evaluation. And let me see the results here. This is the confusion matrix for sure, which you can decide and see the performance. For the hierarchical clustering, actually, it takes some time. We'll explain how the hierarchical clustering work when we discuss the types of clustering, but it really takes some like very like a long time comparing to k-means, so we need to wait a little bit. For sure, you can also change some parameters of the run. Here you can also, like the k-means, you can change the distance function. Here they are using the Euclidean distance. You can use the Manhattan. You can use any other function. You can just click here. For example, you can use Manhattan. For example, the two more famous ones are the Euclidean and the Manhattan. Okay, anyway, so let us just see the results. The result here is 50.4. Okay, and this is the confusion matrix. It's not that much good actually. Okay, despite it looks that this one is good, but overall it is not that much good. Let me just see if I can just try some filtered clustering. Okay, this one. Oh, okay. Let us just say okay here. And let me just see the run for that. This one I get 51.65. Okay, and this okay seems to be better actually than the k-means, the normal k-means. For sure, you can maybe change some of the parameters here if you wish, and you can compare your results. But as I said, maybe because this is a fabricated or generated data set, the results is not that much good. You can see in your case how the k-means and other type of clustering will perform, and whether you can decrease the number or the percentage of incorrectly clustered instances. Okay, so we don't look at the actually k means. Don't look at the mean square error within the each cluster. That is something else actually. Okay, because for sure, whenever you increase the number of clusters, okay, the k means inside the cluster will increase. Why? Because the number of instances within the cluster will decrease. And this means that within the cluster, the mean square error will increase. So this will not give us some real indication. Okay, because this you will keep just increasing every time the number of k, and you will notice that the mean square error within the cluster is increasing, which does not reflect the reality. Okay. So anyway, let us, I think this was helpful. If you have any question or comment, for sure you can contact me at any moment of time. I wish you all the best.